Here we go with section 6. In this section, we're going to be talking about square roots and cube roots. So we're basically doing the opposite of what we've been doing with our exponents so far this chapter. So if we read through the top here, numbers like 9, 25, and 144 are perfect squares because they are squares of integers. The opposite of squaring a number is finding the square root. Okay, so basically what that's saying, 9, 25, 144, if we pick on 25, so 25 is a perfect square because 5 squared equals 25. So therefore 25 would be a perfect square. Okay, then a radical sign, which is this sign right here, is used to indicate a non-negative square root. Every positive number has both a positive and a negative square root. Okay, so for instance, the square root of 36 is 6 because 6 times 6 equals 36. There's little times there in between. Then the negative square root of 36 is negative 6 because, again, the square root of 36 is 6. Negative on the outside means we have a negative answer. Then if you ever see this plus or minus here, that means we're looking at the positive and the negative square root of 36. So we have plus or minus 6, which could also be rewritten as 6 or negative 6. Now, a negative number like negative 36 has no real number square root because the square root of a number cannot be negative. So that negative must be outside of the radical, not inside. All right, if we take a look here, find each square root. So with square root of 9, I want to think what times itself equals 9. So that would be 3. Then I have negative square root of 64. So again, what times itself equals 64. Negative on the outside, so 8 times 8 is 64, so our answer is negative 8. For C, we have plus minus the square root of 4. So I know I'm going to have a positive and a negative. And then 2 times 2 gives us 4, so we have plus or minus 2. Then this last one, the square root of negative 81, where the negative is on the inside of the radical. If you would go to your calculator, so a little calculator practice here. So your square root, first off, you're going to hit second, and then our x squared, that brings up our square root. Then if we put negative 81, you see we would get an error. It's a non-real answer. So that doesn't mean we typed anything in wrong. We would double check that just to make sure. But there is no real solution. Because if you think about this, what could you multiply by itself to get you a negative 81? Well, if you're looking at just 81, we're thinking about 9. So a positive 9 times a positive 9 gives us a positive 81. A negative 9 times a negative 9 would, again, 2 negatives give us a positive 81. So you would have to have a positive 9 and a negative 9. But now we're not looking at the same answer, so therefore there is no real solution. And that's why we can't have a negative square root. Okay, so taking a look at the next part, estimating each square root to the nearest integer. So nearest integer. That means square root of 33. 33 is not a perfect square. So I want to think about what perfect squares is 33 closest to. So if I go through my list, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. Okay, so right there, 33 is between 25 and 36. It is closer to 36. Therefore, it would be closest to the square root of 36, which is 6. So to the nearest integer, it would be 6. Okay, now if we continue that idea, for negative square root of 129, so up here, that was 6 squared, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, and 12 squared is 144. Okay, so again, 129 falls between 121 and 144. It is closer to 121. So since we're just going to the nearest integer here, it's going to be closest to the square root of 121, which is 11. We have the negative sign outside, so our answer is negative 11. Now be careful with questions like this. We might ask you to estimate to the nearest tenth, hundredth, etc., etc. So you would have to go a little further than that, but if it's just the nearest integer, find the perfect squares that are closest to that number and then go from there. Okay, so that's square roots. Next, we want to talk about cube roots. So a cube root of a number is one of three equal factors of the number. The symbol is our radical sign with a 3. It's used to indicate the cube root of a number. So every integer has exactly one cube root. The cube root of a positive number is positive. The cube root of 0 is 0. And the cube root of a negative number is negative. So notice, we can have negatives now. So we want to find each cube root. So the cubic root of 343. So what times itself 3 times would give us 343? Now, I'm not looking for division. We do not divide. So if you don't know your cubes, a lot of times we know our squares off the top of our heads, but if you don't know your cubes, you might have to do a little bit of guess and check. So if we go to our calculator, 343 is kind of a large number, so I'm going to start with 8. So 8 to the third power would give us 512, so a little too high. And next I want to try 6. So 6 to the third power. It's 216, so now we're a little too low, so right in the middle, 7 to the third power. So 7 times 7 times 7 is 343. So the cube root of 343 is 7. Okay, next one, the cubic root of negative 729. So again, what times itself 3 times will give us negative 729? Well, if it's a negative, we know it has to be negative, so I'm going to go ahead and fill that in now. So again, if you don't know your cubes, we're going to guess and check it a little. So I already did 8, 6, and 7. All of them were a little too low, so if I just go up one more, 9 to the third is 729. So the cubic root of negative 729 would be a negative 9. And last one like this, cubic root of 64. Now be careful, 64 is a perfect square, but it is not 8. 8 would be, if we're doing the square root of 64, I want the cubed root. So all of these were too high. So if I go a little lower, let's try 3 to the third, be 27. Still too low now. So 4 to the third, 4 times 4 times 4 does give us 64. It was a positive, so the cubic root of 64 is a positive 4. Now some of these you'll learn if you want when you take a test or quiz, if you want to just make a list of them as soon as you get your test or quiz off to the side of all your perfect squares, all your perfect cubes. You could do that. That will help you out. Okay, so estimating the cubic root of 83 to the nearest integer. So same idea. All right, so 1 cubed, 1 times 1 times 1 gives us 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed, so 5 times 5 times 5 is 125. So I know that 83 falls in between these two. It is closer to the 64. And we know that the cubic root of 64 is 4. So therefore, to the nearest integer, the cubic root of 83 is 4. Which, if you would just double check here, on your calculator, if you hit math, then we need to go down to the fourth one. That gives us our cubic root. And we were working with 83. So cubic root of 83 is 4.36, etc., etc. So to the nearest integer, that would round down to a 4. But we might ask you to do a problem like that without a calculator, so make sure you're able to do that. All right, so there's your lesson on cubed roots. And we have 2 for you to try. So we have find the square root of 121, and then find the cubic root of negative 216. All right, so what times itself is 121, and what times itself 3 times is negative 216. All right, it's the end of this lesson.